So you joined me at a slightly different angle today. I just thought I'd mix it up a bit. And we're going to be looking at this darn clock. It seems like I'm always talking about clocks. Anyway, I bought some LEDs. I'll pull one out and show it to you. I haven't actually tested them yet, so fingers crossed it works on camera. But these are flashing LEDs. So let's make sure I get it. So they're candle LEDs. You can see they sort of flicker a little bit. This battery can't provide a lot of current, so maybe it's easier if I do it like that. Yeah, you can see that. A nice sort of flickering. So that's what we're going to go for. So do these have tiny little chips in? Yeah, they do. Let's see if we can. Yeah, you can kind of see where where the LED part of it is, and where the chip part. It looks like a weird spider doing some welding. Sorry, it's swimming all over the place, but I'm trying to hold it steady while looking in the viewfinder. Anyway, so those are the LEDs that I'm going to be using. These came from Bright Components. They're a company I buy a lot of things from on eBay. They could deliver quite quickly, basically. They're going to be more expensive than buying them from China, though. But I only needed a few, so I just ordered them quickly. One extra thing that I've done with this is I hooked it up to an MSF receiver. Now, this is one of those MSF receivers. Let's get all these cables out of the way. So an MSF receiver like this one here, it picks up a 60 kilohertz signal from a transmitter. The MSF transmitter is in Anthorn in Cumbria, and it's part of the National Physics Laboratory, which sounds pretty darn awesome. Essentially, the transmitter sends out a series of 60 bits, and those represent the time as reference to an atomic clock. So you can see we've got like a ferrite rod here with some wrappings corresponding to the wavelength of 60 kilohertz. And we've got a small crystal on here. We've got a chip on board. Is that what that's called? A cob? And some pinout thing here. You've got power, you've got T-con, which is this yellow one. That's the signal going to the Arduino. Next to it, we have one that's called PON, which is power on something. It goes to negative though, so maybe it's power on negative. I don't know what that stands for actually. And then we've got ground, and then one that should be unconnected, but I soldered a wire to it. Didn't really need it, it turns out. I picked this one up for about £10 some years ago from a place called PV Electronics. They're still around, so you can still get them, but they are actually quite difficult to get hold of on sort of other channels, but I'll put a link in the description. Now, £10 might sound pretty expensive in comparison to something like a GPS module, which does quite a lot more. Gives you the time, but it also gives you your location, altitude, all sorts. You can read off all of the NMEA codes. I think it's NMEA might be. But actually, this has its advantages. It's a lot lower power. You can put it into a low power state. You can also just run it constantly at I think it's something like 10 milliamps is what it draws. But it also has a simpler output. It's just ones and zeros essentially, highs and lows. So more simple microcontrollers can read it without having to have a serial interface like you would need if you were going to read the GPS data. But I wanted to find a cheaper solution, hopefully. I don't know whether it's going to really work, but I picked up a couple of these clocks. These are world clocks. So I found them on Amazon. It's described as a world clock because it can receive signals from, what is it? It's WWWB in America, Japan, it's got the JJY, Europe. Well, actually, MSF also works in Europe, most of Eastern Europe, in fact. But there is a transmitter in Germany called the DCF transmitter, and that this one can receive that as well. And so I bought two of these to try them out. I've turned one on and tried it in my house, and it works just fine. You set your location, and it will activate the relevant transmitter and pull in the time. And it does that really well. Oh yeah, and also these were £3. So I'll put a link in the description where you can pick them up. They were really, really cheap. And I've been playing with it, so let's just bring this over so you can have a look. Push these things out of the way. So I've been playing with this. As you can see, it's got 3 crystals. I don't know if you can see that, hang on. There we go, that should be somewhat in focus. But we've got 3 crystals on board. We've got our little sort of ferrite rod and some windings, but I don't know how they're managing. I suppose it's just an antenna and it's going to filter it all out. And we've got another chip on board and a lot more pins. So the previous one only had 5 pins, 4 of which were used. So we've got standard things like VCC and ground, but we've also got other ones like SS1 and SS2. Now SS1 and SS2 are the transmitter select lines, and I think for MSF, I had to look this up. I actually found what I think the module is. I think it's based on a CMAX sort of design, and it's a CME 8000, and there's a datasheet online available for it. I'm a bit stupid to figure it all out yet, so I'm still working on it. But they've got a sort of truth table for the SS lines, so the select ones. So I think they both go to ground, and that selects the MSF receiver. Then you've got clock, and I probed out the clock when it was working, when I had this one on, or the other one, the one that I tore this one out of. In fact, I still have it available, or sort of plugged into my scope it was. So the clock signal was 1024 Hertz. Then we've got another one that's data ready, and this one just goes high when it's going to kick out data. Then you have data. This is just a single line for the data. It goes high and low. Then 2, unfortunately covered up by this big black blob, which I tried to clear away but unsuccessfully. Now I think under those 2 there, I'm not sure which one's which, but sort of an informed guess tells me that's the data clock line. And the data clock line on the clock itself looks to be 1024 Hertz as well. And then next to that we've got BSI1 and BSI2. I think this one's BSI2. It's right next to BSI1. It's right next to BSI1, so I think that one's BSI2. Other way around, yeah, whatever. Anyway, that's a bit strength indicator. And what that means is they're high or low depending on how much confidence it has in decoding the signal it's received. And again, there's a truth table for that in the datasheet for the CME 8000. And then next to that, we've got hold. I don't really understand what that does yet. And we've also got PON. I think it's the power on thing. So you enable that to go to power the module, or put it to ground rather, to power the module. So I've got it hooked up on my breadboard, and to get the 1024 Hertz, I'm using my little timer that I knocked up using the 4060 and 4027. I only break out the 2 Hertz, 0.5 Hertz and 1 Hertz on here, but if I shove a pin into the 4060 there, I can get 1024 Hertz out, and I'm using a microcontroller, plus an LED on one of the bit strength indicators, the only one that really should be on when it's sure it can decode. And I've been trying to read the data. However, I'm not doing a great job so far, so I haven't finished it. So this £3 little module may or may not work. But we've still got the other one, and that's what I've been using. And so I've sort of programmed this nano up to control this clock. Now you might ask, why don't I plug this module straight into that clock? Well, the trouble is, this module requires you to have an interrupt pin, and they're both being used on this IV-3 shield, so I can't. But I have got just enough space, if you can see in there, to slide in an Arduino Nano, power it from the top header here, and feed in the data via the serial input. So I can throw it into the RX pin and control this. And that's how you generally control this clock without external things like a DS1307 or something like that, is you send it a serial string. So that's what I'm going to be doing. Probably not today. I think we're just going to solder in the LEDs today just to see what they look like. So these LEDs fit in really nicely into these holes, so they're going to point directly upwards. Now I read the instructions, and it says the cathode, that's the short leg on an LED, the negative essentially, will need to go towards where the diode indicator is, where the D6 is. So actually they go negative, 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 negative. So backwards and forwards like that. So let's bend these legs around and maybe cut them off, and then pop it in. There we go, I've shortened the legs on this, so this one should just slot right in, hopefully. Oh, come on, you were doing it just a second ago when I was measuring up. There we go. Perfect. And we can see there isn't too much sticking up on the other side. Actually, it's probably a little bit too little showing there, but it is at least on the pad. So let's solder that in and then we'll see how good it looks when lit up. That's one. And now we'll just gingerly do the other one. There we go. Now let's light this bad boy up. Ouch, burnt myself. All right, we'll just slot that in. And get a power supply. Right, hopefully it's programmed to illuminate these LEDs as standard. Otherwise we'll have a bit of a problem there and I'll have to go out and figure that out. So, you can probably see it's on. It's very dim. I don't know whether you can PWM these candle LEDs, so we might have to disable the PWM on that. But it's certainly illuminated. Is it? No, I don't think that LED's on. I've soldered it in the wrong way round. I've misread the data sheet. The instructions. Damn it. Oh well. At least we've only done one. There we go. Okay. Now let's solder it in the other way round. Which means bending this thing round. That's going to be a pain. I hope they don't snap. So I only have 5 and I've already messed one up that I haven't told you about. PCB holder to the rescue. Hopefully this will help me suck out the solder from those holes. Now I'll put the LED in the correct orientation this time, with the anode at the top and the cathode at the bottom. Right, let's get those soldered in. Hopefully I haven't effed up too much. God, this thing is awkward to solder with. Right. You can probably just about see the LED legs hanging down there. They don't appear to be too close to the board, so I'm fairly happy that that's okay. So let's power this on. Please work. Well, no. Well, that's a wee bit embarrassing. I was trying out a single LED on here, and of course I should have looked at the schematic, because in the schematic it shows me that 2 are connected in series. So each of those 2 are connected in series with each other. So unfortunately it wouldn't work with just one, so me flipping that around didn't make any difference whatsoever. So I'm just going to put them all in the way that I think they should go, and I'm probably going to have to swap that one around because I can't remember at which point I decided to look at the schematic and whether I'd swapped that around once or twice. So we'll solder these last 3 in and then I'll power it up and we'll see if they come on. I don't know whether it's a case that I also need to change something in software, but we'll just put them in as we are. Here we go. As I said, we might need to take this one out, so let's just power it up and see, shall we? So in the instructions it said be careful of the ICSP header, ISCP, whatever it is. It's the in-system programming thing, isn't it? But so what I did was make sure that the leads went either side of one of the pins there. So it isn't touching, but you know, it's darn close. But we'll just try it out anyway and see. Yeah, I've got that one the wrong way round. That's frustrating, but that looks kind of cool. So you can see them flickering away. I've altered the code on here so that pin 10, which is the one that these LEDs are connected through a transistor on, it's just on constantly. It's on high all the time, so it's not being driven with, I think it's on timer 1, it was being PWM'd at something like 250 Hertz, I think. But I like that. It looks like it's slightly broken. Should we come up? Whoops. Come a little bit closer so you can see that. Yeah, it kind of looks like the power's failing a little bit. I like that a lot. So I'm just going to take this out and then swing that other LED over, and then we'll be done. There we go. They're all lighting up now, thankfully. It looks a little bit dimmer than the others. I don't know whether it's because I've heated it up too much or not, but there we go. Let's take a quick look at the code for this, and what I'll do is I'll plug this in and we'll leave it and see if it will pick up the time. Now it's got this these nice flashing LEDs on them. So I need 5 volts and I need that one to go into RX. So these are our two sketches. We've got one for the IV-3 clock and one called the Arduino Atomic Refresh. And so this is my rewritten code from when I originally used the MSF time library. So if we have a look at the IV-3 clock, there's a lot of comments here. This is pretty complex code. There's a lot. I mean, if I scroll down really quickly, you can see that there's a lot. It goes down to about 1,000 lines. But there's various functions in here to be able to set the time. And it also keeps time itself. So once you set it, it'll count the seconds for you. But you probably want to keep that time updated occasionally because this will drift. So we've got T to set the time. So you can set it using the sort of epoch time. So the time since, what is it, since 1970 or something like that? 1st of January 1970? I think it's something like that. Someone will probably remind me in the comments what it is, but I'm using the command S just here. This sets the date and time, specifying the year, month, day, hours, minutes, and seconds. And so that's how I'm doing it using my code over here. But I just want to show you some of the complexity of this code as well. So you've got this is sort of their segment array here, but if I go a bit further down, there you go. You can see all of the pins that are being used, which is a lot. And it's also using pin 2 and 3, and both of those are the hardware interrupt pins on the Uno, so I can't use one of those, unfortunately. It also has some some methods in here for using real-time clocks. So the DS1037 you can use, and it uses like the one-wire library. I'm not doing anything with this. I'm basically not changing their code at all. The only thing I've gone in and done is to somewhere in here set 10 to high. So there's not PWMing any of those LEDs. I've disabled that in the code, so it's not doing PWM on the LEDs because I just don't need it to. So that's the code for this, and we're using the serial command to set the time. So this is my Arduino Atomic Refresh sketch. This is not far off from the basic sketch for the MSF time lib. I'll put a link in the description where you can pick that up. Now, if you were using this with the little 3-pound module that I showed you earlier, then that has a low going pulse, I believe, so you have to change some of these settings. But so for me, I'm just I'm kicking out a string once it's in sync. So if in sync, so this is when it gets its first lot of complete data. So it counts these bits and then kicks out the data when it's complete. And so I'm having to format it in a very specific way. So I'm formatting the year as standard. That will come out as 2018, but the month will come out as a single digit if we're in the single digit. So we're in May at the moment, so it would come out as a 5, but I need it to come out as 05. So if the month is less than 10, it's going to add onto my temporary string that I've created here, it's going to add a 0. And I'm doing that for all of the digits that could come out as single. So you'll see it's pretty much the rest of the digits. And then I'm printing that out, followed by a /r character to create the new line. And that sort of initiates this on the serial. So it probably says in here, I think it does say somewhere here that you need to send a certain character, but you need to send an ending line character at the end with the serial data. So that's all there is to it, really. I've disabled everything else in the example for this MSF timelapse thing. So all it's doing is kicking out over the serial monitor. Super easy to use. So let's have a look and see if it's worked. So there we go. It's picked up the time. It's currently about 3 minutes to 7. Exactly 3 minutes to 7 minus some seconds. It is still nice and sunny outside. So I've brought it by the window so it can get a bit of a better signal. You can see it's still flashing away quite happily there. It's running off this sort of UPS supply. So I'll be looking to change that out for just a normal 12 volt power supply. I'm gonna have to go and buy one, I think, because the one that I've got to supply power to this, I want to keep for that. So I'll have to buy another one. Oh, and it's got the date as well, 7th of the 5th. Well, that was a pretty long video for what I was putting in 4 LEDs, right? But I suppose we talked about the MSF receiver, and we talked about the world clock, the potential £3 receiver that works with the WWWB, VB, whatever, the one in America, Japan, Germany, and the UK one. So hopefully spanning much of the globe. But I thought I'd tell you what I'm going to be looking at next. First off, we've got Steve Ludgate has designed some 3D cases for the binary clock. However, I want to give that a rest for a little bit, maybe about a week, partly for my own sanity, but also because there's people across the world that may not have got it yet. So, you know, as soon as everyone from a dude in America and a dude in Australia has got it, and everyone in between, then I'll do the video on the little 3D printed case so that everyone has a chance to get one. But in the meantime, I bought a couple of these. There's one behind me somewhere, just there, in a little E27 screw thing. So these are 12 volt AC or DC bulbs, LED bulbs. So they shouldn't have any drivers inside. It should just be 12 volts, I think. So we're going to test these out and find a way to dim them. I want to use, it's not there, which is very frustrating. I'm not sure where I've put it, but I have a Muirhead capacitance box. So it's like a decade counter, like this decade counter for resistance, which I pull out occasionally and use. And this one's by Sullivan resistance box, and you can select the appropriate resistance that you want to use. But I've got one for capacitance, and it's much cooler looking. Now, I don't want to damage either of these, but I would like to make it have the ability to turn this light up and down in brightness. And I'm just going to do that by attaching wires to the normal terminal points, and then have the circuitry and stuff hidden away. So I don't have to damage it, but it does mean I can get more use out of it than just a bit of technical equipment. And it should look darn cool. So that's what's coming up. So thanks for bearing with me for what is probably a 30-minute video. I mean, I'm not quite sure, but probably it's. All right, I'll see you again next time.